Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode servers. Head to linode.com/changelog.
This episode of the Changelog is brought to you by Hired. One thing people hate doing is searching for a new job. It's so painful to search through open positions on every job board under the sun. The process to find a new job is such a mess. If only there was an easier way. Well, I'm here to tell you that there is. Our friends at Hired have made it so companies send you offers with salary, benefits, and even equity up front. All you have to do is answer a few questions to showcase who you are and what type of job you're looking for. They work with more than 6,000 companies, from startups to large publicly traded companies in 14 major tech hubs in North America and Europe. You get to see all of your interview requests. You can accept, reject, or make changes to their offer even before you talk with anyone. And here's the kicker, it's totally free. This isn't going to cost you a thing. It's not like you have to go there and spend money to get this opportunity. And if you get a job through Hired, they're even going to give you a bonus. It's normally $300, but since you're a listener of the Changelog, they're going to give you $600 instead. Even if you're not looking for a job, you can refer a friend and Hired will send you a check for $1,337 when they accept the job. As you can see, Hired makes it way too easy. Get started at hired.com/changelog. Hello everyone and welcome to another episode of the Changelog. Jerod goes solo on this one to talk with Richard Feldman. They chat about the growing Elm community, some pretty cool asset optimization features built into Elm 0.19, NoRedInk's first production runtime error, and the biggest blockers to folks adopting Elm.
So, Richard, it's been just past 2 years since we first had you and Evan on the show to tell us about Elm, and now we're here to catch up, hear what's new, and learn some more. So, first of all, welcome back.
Yeah, great to be back.
So, 2 years is a long time in internet years. I'm assuming Elm has leaped forward. It's still out there. It's still popular. People still talk about it. I still see people retweeting things that you're saying about Elm. So, before we get into the catch-up, why don't you give the elevator pitch what Elm is and what you use it for?
Yeah, sure. So Elm is a programming language for building web apps. It compiles to JavaScript. People often consider it sort of an alternative to JavaScript frameworks because in addition to being a programming language, it also comes with enough tools out the box to build an entire web app. So we don't really have frameworks in Elm. It's sort of like the language provides enough that you don't need a framework. And so I work at NoRedInk. We make tools for English teachers. And basically, our entire front end, just about, I guess we have some legacy React stuff from back in the day, but pretty much everything is in Elm. And it's about 250,000 lines of code. Our first commit was in 2015. So it's been somewhere between 3 and 4 years that we've been doing it in production. Basically, everybody who works on the front end writes Elm full time. It's been really great. Some of the stuff that's cool about Elm is one, it's really, really reliable and easy to maintain. It has a really amazing, friendly, helpful compiler with really nice error messages that kind of tell you about problems before they happen to end users. And as a consequence of that, I used to be able to say that we'd had 0 runtime exceptions in the entire time we'd had Elm deployed. However, unfortunately, last year it happened. We finally, yeah. So now I have this graph that I like to show, which is because we have a logging system that tells us if anything crashes. And so now the chart is 60,000 JavaScript runtime exceptions, from our JS code. And then it's not 0, but it's 0 pixels on the graph.
Because, the blip.
Right. So it is possible. It can technically happen.
What happened?
Well, it's actually a funny segue into Elm 0.19. It's a thing that is no longer possible in Elm 19. So that the root cause there. Basically, there was a function called debug.crash, and it really did what it says on the tin. If you call it,
sounds like you shouldn't call that in production.
It's funny you should mention that because you shouldn't call that in production. But we did, and sure enough, it got run and then it crashed. So in Elm 19, there's actually, when you run an optimized build, there's a new compiler flag called -- optimize, which I'm sure we will get into because that's one of the sort of banner features of the release. When you run that, one of the things that it does is it says, hey, you're still using some debug functions. Take those out before building for production. So that would have prevented us from having any runtime exceptions, but unfortunately that option didn't exist back then. So we blemished our previously unblemished record. But I think still, it's funny because when I we found out about it and I tweeted about it, that got like way more retweets and likes than my previous comments that, hey, it's still been, this many months or this many years without any runtime exceptions. And I have this theory that maybe it's more credible if you say it's been like, a very small number instead of 0. Because
that's right.
I guess people kind of wonder, well, maybe you just don't have your logging set up right. But we did.
Well, it's like even Superman has his kryptonite, like 0 is just, it's almost unbelievable because it's statistically like, I mean, then you're still at a blip, but it shows that, even Elm and NoRedInk are humans as well.
Absolutely.
They're not perfect.
Yeah, no, we very much are not.
Well, let's talk a little bit about the company. So I mention NoRedInk often because there are a handful of businesses who have done what you all have done in hiring Evan and allowing him to work on Elm. And I like to just promote that activity. Another one that comes to mind is Shopify, which hires Sean Griffin to work full-time on Rails. And I think they're hiring other such positions like to fill out even more of their infrastructure team. Dockyard hired Chris McCord to work on Phoenix. And it's like his job is to work on Phoenix. And that's something that they believe in investing in. So just curious from the business end and from your perspective, like what it's been like having Evan working there, the push and the pull, like has he been able to dedicate most of his time on Elm proper, or does he get pulled into the business things? Help us understand how that's going.
So it's in Evan's contract that he only works on Elm. He's never, so we hired him in January 2016, and he's never done anything like directly for the product. So the product is basically, it's a web application for teachers to help teach their students English, and more specifically writing. Evan basically is really just 100% open source engineer. He just works on Elm. And my boss, full credit to him, it was his idea to see if we could hire Evan. Basically what he said was, to Evan, hey, the reason we want to hire you is that Elm's been really great for us and we don't want to mess with the formula. We want you to keep doing what you're doing. We just want to be kind of more plugged into it. So yeah, I mean, he basically has, complete autonomy to take Elm in whatever direction he thinks is best. And we trust his judgment because that's what's led us to embrace it in the first place. So yeah, I don't know. I guess we're aware that that's not a common thing for a company our size. So for context, we have, I think it's 26 engineers now. This is probably a good time to mention that we're hiring. So if you want to come work with me and Evan on building stuff for teachers, we're super remote friendly. I work remotely from Philadelphia. Evan works from Boston. The headquarters are in San Francisco, but we go anywhere from West Coast Pacific to Central European time as far as time zones go. So the 26 engineers are pretty widely distributed across that. And the overall company is, I think it's 67, I want to say, something like that, like between 65, 70 people. Yeah, so for a company our size to hire somebody to 100% work on open source stuff, I guess is pretty unusual. But like I said, we really wanted to sort of keep the good thing going and to, not mess with the formula that has brought us so many technical benefits.
Yeah, Elm has been much praised for its technical benefits. I'm curious about the community. So it's been 2 years since we've talked, and we like to, keep our thumb on the pulse of like, which direction things are moving. And anytime you have a project or a piece of software which has technical prowess, you always wonder, will it catch on? Will it have a robust community? Will there be people who adopt it? And so, like I said, we're here 2 years later and it's still going, but curious from your perspective, how much adoption Elm has gained and how much the community has really built out around Evan and around your work.
Yeah, it's a great question. So first of all, I think the biggest change that we've seen in the past year, so we started doing this State of Elm survey. And so comparing 2017 to 2018, the biggest change that we saw was actually more people using Elm on teams, like at work, rather than as individuals, as hobbyists. So in 2017, it was something like 18% of survey respondents said that they were using Elm at work. And 2018, it was like 40%. So more than double, which was really fantastic, because one of the concerns with a project like Elm is it's like, hey, this is a new programming language. Obviously, that's a bigger barrier to a lot of teams trying to adopt it than it is to say we're a library or we're a framework. And so there was always that kind of question where it's like, hey, even if this is really great, even if it has all these benefits, is that going to be something that teams are just unwilling to give a real shot to? And it turns out that the answer seems to be actually they are willing to give it a shot, and that's really changing. So as far as absolute growth numbers, we don't really have a great way to measure that. In part because around the time of GDPR, we were like, we could do a bunch of stuff to make the website compliant with cookies and whatnot, or we could just stop tracking visits, and we just decided to stop tracking visits. So we don't really have even like a bellwether of how many people are.
You could have just blocked all of Europe. We've seen a few companies doing that as well.
No, I mean, Elm's really big in Europe. The biggest Elm meetup I ever went to was in London. It was like 100 people. And Oslo apparently is just like a hotbed of Elm activity. Oslo, Norway. There's just like a bunch of, there are multiple Elm consulting companies. There's a bunch of companies using Elm, to build their products. So I think the idea of just like, we'll just ignore Europe, it would be a complete non-starter for us.
Yeah. It's interesting you find so much growth of Elm inside of enterprise and inside of the workplace. Seems like small, new niche languages start off, at least many of them I'm thinking of, in the hobbyist realm. People tinkering, trying it out on their own time, and then maybe it starts to get penetration as they see value or as they sneak it into their organizations often. What do you think is the selling point for Elm that's getting so many businesses to hop on? Is it that example, the one runtime error? I was going to say the zero runtime errors, the very few runtime errors. Is that what gets people to really dive in and try it on work time?
So that's a great question. I want to go back a step though, and just point out that I think Elm, we've gotten definitely increasing adoption over time, but I can't say Elm's like a runaway smash success. It's not like on the level of like a React or an Angular, something like that. I think Elm is like, I like to say we've graduated from obscure to niche, where it's something that, nice. A good number of people have heard of, but a much smaller number of people have actually tried, and an even smaller number of people are actually using it professionally. So I think that's been a really positive improvement, but I can't say that we're there yet. Like Evan gave this talk a couple of years ago called "Let's Be Mainstream." I don't think I can say that Elm is mainstream yet in terms of adoption. Having said that, Evan also gave a pretty awesome talk about sort of like what are Elm's goals, like what does success look like? And one of the things he talked about is actually, getting back to your point about community, the conclusion of the talk was basically, let's try to make a really great community where everybody wants to help each other build awesome things and not worry so much about adoption or, Hacker News or stars on GitHub, and just kind of let those things fall out of having a really happy, successful, functioning community where people are happy. So that's been kind of the bigger focus. There are definitely some things we could do that could, sacrifice Elm's long-term goals for the sake of driving adoption in the short term. And we just kind of said, we don't want to do that. We'd rather just let it grow organically at whatever pace that is. And so far, we've all been pretty happy with that outcome. I have to say, it does benefit companies who do adopt Elm for now, because the result of that strategy has been, intentionally or not, which I don't think it has been intentional since we haven't really talked about it on the core team. But it does mean that there's actually a pretty substantial hiring benefit to companies that adopt it. So we have seen this, and other companies have seen this, that basically there's just more Elm developers out there, like people who want to use Elm at work, than there are companies who have Elm positions, which means that it's actually paradoxically easier to hire high quality Elm developers right now than it is to hire high quality JavaScript developers, because although there are many more JavaScript developers in the world than there are Elm developers, there is an even bigger proportion of JavaScript job openings that they are out there choosing from. So it's sort of like you get to be a bigger fish in a smaller pond by being one of the few companies that's offering Elm jobs. And that's been one of the biggest benefits to us outside the technical realm, has just been hiring. We honestly, the number one thing that we get on our cover letters for why the person applied, they all say the word Elm. It's a selling point for basically everybody who applies for any kind of front end or full stack position. To the point where we've actually transitioned. When I joined the company, which was almost 5 years ago now, we had a really tough time hiring front end engineers. We were able to get back end and some full stack applicants, but front end was just the well was totally dry. Until we started using Elm, and now it's completely reversed, where we now have a much harder time finding back-end people than front-end people because we just get so many applicants who are interested in using Elm. We even get some back-end people who are interested in using Elm. They're like, hey, I'm a back-end engineer, but I'm actually kind of curious about this Elm thing, and that's what got me interested in your job position in the first place. I'd like to kind of do a little bit of Elm stuff, even if I'm mainly on the back-end. It's pretty cool.
That's interesting. It makes me think of kind of on a different angle of the same idea. Not only is it easier to hire because there's less enterprises that are hiring in Elm, but there's also somewhat of a relationship between a programmer who will learn a new thing on their own and who's diving into these niches because they see the technical merits of a language and the quality of that programmer. So it reminds me of actually a Paul Graham essay from all the way back in 2004. Have you heard of this one, the Python Paradox?
Yep. Yeah.
Exactly.
So
you got to put yourself in the time of 2004. But his point was that Python programmers, I just have it pulled up here. Let me read it a little bit. So he says, in a recent talk, I said something that upset a lot of people, that you could get smarter programmers to work on a Python project than you could to work on a Java project. Of course, that would upset a lot of people, right? He said, I didn't mean by this that Java programmers are dumb. I meant that Python programmers are smart. It's a lot of work to learn a new programming language, and people don't learn Python because it will get them a job. They learn it because they genuinely like to program and aren't satisfied with the languages they already know. And so that's that Python paradox that he's talking about. No longer applies to Python, right? Because has gone mainstream.
For sure, yeah.
And you can definitely get a good job learning Python, but it does apply, I think, to niche languages and the kind of programmers that will go out there and teach themselves or dedicate hobby time. They're usually pretty good programmers. So kind of works both sides.
Yeah, I think it definitely correlates with a passion for programming, right? I mean, this is something my my wife likes to say is, she'll point out that your hobby is also your work. When I'm not working on my NoRedInk stuff, my hobby is doing more programming stuff and running the Philadelphia Elm meetup and whatnot.
Right.
So
not fair.
Yeah, and I think I think it's important that our industry not have that as a requirement, that people need to do the same thing in their free time that they do in their work time. But of course, it's inescapable that it's an advantage. I mean, if you're spending more time in engaging with your craft, then you're just on average going to be better. Otherwise, that would be kind of a waste of time. And I mean, as much as I don't want that to become a requirement, I also appreciate the fact that companies benefit from that.
Yeah, it's fortunate and yet unfortunate, it's one of those things.
Yeah, as long as it doesn't become a requirement, I think it's okay.
This episode is sponsored by our friends at Rollbar. How important is it for you to catch errors before your users do? What if you could resolve those errors in minutes and then deploy with confidence? That's exactly what Rollbar enables for software teams. One of the most frustrating things we all deal with is errors. Most teams either A, rely on their users to report errors, or B, use log files and lists of errors to debug problems. That's such a waste of time. Instantly know what's broken and why with Rollbar. Reduce time wasted debugging and automatically capture errors alongside rich diagnostic data to help you defeat impactful errors. You can integrate Rollbar into your existing workflow. It integrates with your source code repository and deployment system to give you deep insights into exactly what changes caused each error. Give Rollbar a try today at no cost to you. No credit card is required. Our listeners get access to the Bootstrap plan with 100,000 events for free for 90 days. To get started, head to rollbar.com/changelog.
So Richard, as you said, Elm is moving from obscure to niche, and its impact has been, I would say, more than niche and more than obscure, because we've well documented on this show. And one of the things I love about the changelog and why we try to stay as polyglot as we can, even though that means we dive into things that sometimes we just can't quite swim that deep, is because the proliferation and the moving of ideas across different camps and different languages and different communities is hugely valuable. And I think 2 years ago when you and Evan were on, I asked Evan about the feeling he gets when some of his great ideas and some of the things that Elm has really paved the way for, thinking about the Elm architecture, thinking about just the niceties of the compiler. And these ideas have either been, borrowed, or from the great artists have been stolen and taken to other languages, other projects, other frameworks. Really a neat thing that has happened. But that being said, somebody who knows JavaScript today and doesn't know Elm can benefit from a lot of the stuff that Elm brought to the table. But what are still some reasons in 2018 to give it a try, even though a lot of the great ideas have been, moved around to other places?
Yeah, so it's funny that you mentioned that, because from my perspective, I've developed sort of a strange relationship with the idea of Elm's ideas kind of proliferating in the world. So the big one is the Elm architecture, which essentially is, I think, Redux is very similar to the Elm architecture in a lot of ways, and that's sort of like the biggest way to do application state management in the React ecosystem, certainly, and even in like Angular and Vue, there's sort of like ways you can opt into that, which some people do. Whereas in Elm, it's sort of a foundational concept. Everything's built on top of that. It's the only way to manage app state, and there's actually no other source of global state at all. And one of the things that's interesting to me is that if I talk to a JavaScript developer, it's pretty common, like who's never used Elm, it's pretty common that they will say, like the Elm architecture seems really cool, and I appreciate some of the simplicity that it brings to organizing your app state. And if I talk to Elm developers, like who have been doing Elm for even a couple of months, nobody mentions that. It's all other stuff. That's just sort of like the table stakes in Elm, and because it's this kind of foundational primitive, the stuff that people talk about are things like, I really love the compiler error messages, or I love how everything in the ecosystem just works well together. Or now with Elm 0.19, two of the things that people commonly mention are, one, my project builds so fast because there was a big speed up in the compiler. Evan basically rewrote all of he rewrote the parser, and then he rewrote the exhaustiveness checker and the type checker. And basically, by the time he was done, pretty much all of the insides had been rewritten for speed. And the result is that somebody posted, they had like a 50,000, just shy of 50,000 line of code Elm project with something over 100 files and so forth. And the entire thing from scratch, building it plus all of its dependencies, like on a fresh Git checkout, was like under 2 seconds. And that's like compiling it, type checking it, spitting out the compiled JavaScript, like everything start to finish was under 2 seconds. And that's not even an incremental compile, which of course are much faster. So that's like, I think about like how many people's, Babel, which is JavaScript to JavaScript, builds, at that scale, are running in under 2 seconds for a fresh build, let alone for an incremental build. And that sort of, becomes a selling point, becomes something that people are excited about. And so I think about it in terms of two things that are really exciting to me about Elm. One is the tools, so that is like the compiler and the tooling around it, like the package manager. And the other one is the ecosystem, where basically everything is built in terms of Elm, and I don't really have to worry about compatibility like I did in the JavaScript world. I basically, whenever I install a new package, I kind of expect it to just work immediately. I'll say install it, and then I expect to get the same experience I would get as if I were just using a new core library that shipped with the language. It's sort of that level of smoothness. And I get, so asset size is, I guess, another another thing we should talk about, because that's maybe the biggest selling point of Elm 0.19. But it's relatively new, so I don't hear a lot of people talking about it yet.
Well, it was news to me. Just announced the blog post, which is linked in our show notes, August 21st. So we're recording this October 10th, a couple of months back. But this one didn't make the headlines as much as some of the other things I've seen from the Elm community, even though it's a pretty big deal, especially nowadays where we're trying so hard to get the time to first paint down to as small as possible for our web apps so that they can reach as many people as fast as they can. Elm 0.19 has made huge strides with regard to bundle size. Give us the details.
Yeah, so basically, the comparison point that we ended up using was the real world app. So this is basically a project that's sort of designed to be a bigger cousin to To-Do MVC. So the basic idea is they have a really detailed specification for here's how to build this. It's like a medium clone. It's called Conduit. It's basically you can sign in, sign up, post an article, view a feed of articles, favorite articles, follow authors, unfollow people. You can edit some settings. So pretty typical web app type stuff. And they basically have a really detailed spec, and they provide all the styles for you. And they have a spec for both the front end and the back end. So if you want, you can try out, hey, what does it look like if I'm running this application on a React front end and a Django back end, or a Angular front end, or with a Laravel back end, and all those different combinations.
That's a great idea, by the way. I think I remember seeing that. It's very useful to be able to swap those in and out and just see how it reacts, right?
Yeah, and it's a really cool project just to be able to compare. Like if I'm trying to see, hey, how would this thing be done in this particular technology? I want to evaluate that technology. Just having a sort of substantial code base to look at it to say, okay, so I see how this thing maps to that other familiar thing, technology that I know. So we have an Elm implementation of this. And one of the things that's kind of cool about this is that these are all projects where the goal is to show best practices, not to like tune to benchmarks, which is always, a concern with micro benchmarks is that it's like, well, how much of this is like actually real world versus, something that's just been kind of like tuned to do the best numbers on the benchmark possible. And pretty much all of these are like people just built the apps to do a good job showing like how to do things right. And so what we saw was basically the sort of the punchline of the blog post is that the like React, Ember, and Angular ones have anywhere between, I think it's like 105, something a little bit over 100 kilobytes of minified and gzipped assets for this whole application, which is usually like, I don't know, a couple dozen files and so a bunch of dependencies and so forth. So 100K is and I think down to like in the 70s depending on which of those more popular frameworks you're using. Whereas the Elm one, the entire compiled asset size minified gzipped is 29K, which is actually just smaller than React by itself, which was a really cool result because that basically means that if you're doing a React version of this, even with the most aggressive possible code splitting, you still couldn't get it down to as small as the entire Elm app, with no code splitting, which was really surprising.
How much of that 29 kilobytes, just if you could break it out, would be application code and how much of it would be, framework or architecture code? Do you know, even percentages?
That's a good question. And it kind of gets into why it's hard to measure. So the reason that Elm got this to be so small is basically that what 0.19 introduces is function level dead code elimination. So the way that works is, so ordinarily you have your application, you install some packages that you depend on, and by default, in the old world, you would just get absolutely everything that you installed with the package. All the code in that package gets compiled into your bundle. So then you have module level dead code elimination, aka tree shaking, which is kind of the target in like the JavaScript ecosystem is like, hey, if everybody uses ES6 modules, then we can get tree shaking, and that'll be great. And so that's sort of one level of dead code elimination, where if you don't import a module, then it gets excluded. It gets stripped out of your compiled asset bundle, which is cool. Right. But there's one more level than that, which is function level dead code elimination, which is essentially saying, I import this module exposes 100 functions, let's say. If I'm only actually calling 3 of those functions, that's all I'm going to get in my compiled output. The other 97 just will get stripped out. which means that basically it doesn't really matter how your modules are organized anymore. You can just put your functions wherever makes the most sense organizationally. And it also doesn't matter what you're importing, like which modules you're importing. It only matters which functions you're actually calling. Those are the only ones that get used.
That's super cool. So it does all the transitive dependencies and stuff to figure out which functions those functions are calling and so on. So you're not gonna be missing a function at the end of the day.
Exactly. Now, this is really cool, and it's one of the big reasons that Elm 0.19 was able to get such a small bundle size is that we, however many dependencies we pull in, it doesn't really matter how big they are. All it matters is how big are the things we actually use. And the reason we're able to do this is that Elm has its own totally separate package ecosystem from NPM. So like that whole SPA example doesn't actually use NPM at all. It's just only using Elm packages. And so as a consequence of that, it means you get this system-wide dead code elimination, which is really great. But it also means that it's kind of hard to measure like what percentage of this is X versus Y versus Z, because it's kind of like, well, what even is Elm's baseline? Like how much of that? And the answer is, well, it kind of depends on how much of it you're using. So that dead code elimination applies to sort of Elm's standard libraries just as much as any package. So it makes it pretty tricky to measure. I guess what you could do is you could kind of like do surgery on the compiled JS and kind of like map things back and then like sort of categorize all of them and say, oh, this came from here and this came from there. But I don't think anybody's ever tried to do that. It sounds like a bunch of work.
Yeah, I was gonna say one thing you could do from the other direction is say, okay, how much application code do I have, right? How much application code have I written, and assume that you're using all those functions, because why would you write app code for a demo that's unused, I guess?
Sure.
And then say, how big is that if I just minify it or do whatever. I don't know, maybe Elm can't do that. It can't just like boil this part of the world without boiling the entire thing, especially with its checking and stuff.
Right. Yeah. I don't think there's a way to directly say like just compile this application code without its dependencies, because
it wouldn't compile.
Exactly. Right. It depends on those. So
I'm still thinking I'm in the minify world. I'm still thinking just minifying all this down, but
right.
It's actually compiling. Okay.
Yeah.
So
and what's really cool about that is that it's a benefit that actually gets bigger the bigger your code base is. Like if you have, an example that's like, let's say 10 times the size of this application, and you've got a bunch more dependencies, because the bigger your project is, just naturally, the more dependencies you're going to end up having as a general rule. The more you benefit from this, because each of those additional dependencies would otherwise represent all of that code coming in. But instead it's like, oh no, we're just going to get what we actually use. And the other cool thing is that Elm shares transitive dependencies. So if I install two packages that, let's say, both of them depend on the JSON library, it's going to find some version of the JSON library that works with both of those packages and only install that once. So it can do the dead code elimination, not only across your direct dependencies, but also across your indirect dependencies as well, with just the one shared version between them. So you really end up with kind of the minimal set of dependencies you can get. There's some other cool stuff that it does, like automatic record renaming, like field renaming. One kind of cool thing about that is it does stuff where basically if you've got records, which are kind of like JavaScript objects, but simpler, they don't have like prototypes or this or anything like that, and they're immutable. But basically you'll say, like, maybe you'll have a user record that's got fields like username, email, stuff like that. When you run Elm make with the optimize flag, what it'll do is it'll actually compile those down to the smallest JavaScript field names it can come up with. So instead of username and email, it'll compile them down to like A and B, which is ordinarily not something that's super safe for a minifier like Uglify to do, because you might be potentially relying on those with like dynamic field access using a string or a variable. But in Elm, we know that that's not going to happen with these records, because that's just not a feature in Elm. You can't do that. You can only access them with a dot. So because of that, it's safe to rename them. And one of the cool things, which granted probably doesn't make a big difference in practice, but which I think is really cool, is that it actually goes through your whole program and counts usages, like how many times this field is used, so that it can use all the single letter ones for the most used fields. And then when you run out of single letters, then it can move into, two letters or something like that, which is just, like, how much does that actually save in practice? Okay. Yeah. Probably doesn't really matter. But it's a cool example of like how much the compiler knows about your whole program.
We need to sit Evan down and tell him about the law of diminishing returns.
I honestly think that was one of those things where it was like he had to track it anyway. And so it was kind of like, well, how should I distribute these things? Yeah, might as well just count.
Well, that's very cool. Function level dead code elimination. That's the first I've heard of that. The next step is now line level dead code elimination. So lay that challenge out there. Line by line, he can do it for the next version.
Speaking of diminishing returns, I mean, there are other potential optimizations out there. Like it could go even further by like eliminating branches of conditionals that can't possibly get run because of like you're using this library, but we know that like it's not possible for that branch to get run. However, that's like another really big project. It's kind of a whole different level of challenge. And at this point, it's like, okay, basically Evan put something out there about the design for code splitting, because right now Elm does not have like a first class code splitting mechanism. And kind of the goal was, well, let's see how much the dead code elimination does for us. And then let's see if A, that's something that there's actually demand for. And B, if there is demand, let's see what people's, code bases actually look like so that we can kind of design the feature that, is going to make sense for how their assets end up being in practice. Because this is kind of a whole new ballgame. We don't really know what it looks like to, maybe it turns out that actually if you try to code split along these module boundaries, that you end up with actually more than you would have before because you lose out on some of the code splitting benefits. So we're going to have to see how those things look in practice before thinking about, even further investments into asset size.
So when you say code splitting, you're referring to instead of having a single bundle, you'll have multiple bundles of smaller size that are kind of loaded dynamically. Is that what you mean by code splitting?
Yeah, exactly. Sorry, I should probably define my terms.
That's all right.
Yeah, so code splitting and lazy loading. The basic idea is, let's say you've got a single page application. So you've got, you're going to download one HTML file, and then when the user transitions to different URLs, that's actually all going to happen on the client side. You're not actually going to get a page refresh and a flash of white on the screen. All that's going to happen is that the JavaScript code, the compiled JavaScript code, is going to go and do HTTP requests to the server saying, hey, give me the data I need to render the next page. And the idea behind code splitting is you're not only going to say, give me the data to render the next page, but also you're going to say, give me the code to render the next page. So that way you don't have to download, let's say you've got, you end up with like 50 pages on your web app. You don't really want the end user to have to download all of that when they do the first page load. You'd rather have them download just enough compiled JavaScript to render that first page. And then when they transition to a different page, you can then say, okay, I'll on the fly load the code for this new page and then execute it. So this is, as applications get bigger, this is something that people commonly have demand for in the JavaScript world. That may very well turn out to be something that there's also demand for in the Elm world, just because why wouldn't there be? But we don't really know what the design constraints would be yet. I mean, one of the things about performance optimization is that the bottlenecks are always where you least expect them. So now that we have this sort of ecosystem-wide function-level dead code elimination, what does that mean for code splitting? How does it impact it? We don't really know because no one's really ever had it before.
Right. So now that 0.19 is out there and you have this dead code elimination, which sounds like be a straightforward upgrade and then recompile, would be you could at least test. I mean, have you guys tried it NoRedInk and just seen your bundle size decrease from version to version, or is it not that simple?
It's not that simple because we are still blocked on some of our dependencies not being updated yet. So we're you
don't have the goodness yet.
Not quite yet. And we're jealous of the companies that, all of their dependencies have already been upgraded and they're already, gushing about it in Elm Slack about how awesome
you're
it is.
You're like an Android user on like 3 versions back on their OS, man.
Well, 1 version back, but no, I mean, we're very excited about it. It's something where we actually track, what are our compiled asset sizes for each of our different routes. And so we'll be able to do a pretty cool before and after. I mean, for us, honestly, the bigger benefit is the compile time, because now, we got 250,000 lines of Elm code. You multiply, really fast compile time savings across a big enough code base, that adds up to a lot of increased developer productivity.
Absolutely.
So, looking forward to that.
Let's go back to the packages real quick. So one of the reasons why this is possible, this function level dead code elimination, like you said, is because all of the packages are written in Elm on elmling.org package manager. And so NPM isn't even touched. Now, the gift and the curse of NPM is there's so much out there.
Yeah.
Right. I mean, every package and every piece of code in the universe is on NPM somehow. So when we talk about community and advantages, how much is Elm at a disadvantage in terms of packages that developers need versus NPM? Like, I just think of that because of the limiting factor of you're waiting on some packages haven't been updated yet, and I wonder how big is the package ecosystem?
That's a good question. I don't know the exact number of packages, but I know that NPM being the biggest in the world is a lot bigger. There's no doubt.
Yeah.
I see it in a couple different ways. So one is Elm does have JavaScript interop. So if worst came to worst, if I were starting a brand new project and I really needed to do, there was some package on NPM that I was like, I can't live without this package. I wouldn't necessarily have to rewrite it in Elm. I could probably just do JavaScript interop and just get by with that. Of course, if I do that, then that chunk of code doesn't get me all of Elm's guarantees, all of its benefits. The function level dead code elimination, of course, is not there.
Right.
The only way to get that I'm aware of in JavaScript is to do it with the Google Closure compiler. That is like an uglify alternative that has an advanced mode, which as long as your code abides by certain rules, it can do function level dead code elimination. However, in practice, it seems like there aren't a lot of code bases out there that actually happen to abide by those rules such that they can use it. As far as I know, the only community that really makes good use of that is the ClojureScript community, because ClojureScript was specifically designed to emit JavaScript that could be used with Closure compiler on advanced mode.
Smart.
Yeah. So basically, I think now ClojureScript and now Elm are the only two communities that have the function level dead code elimination. Although I think ClojureScript tends to do more in terms of wrapping JavaScript libraries as opposed to sort of rebuilding them from scratch, whereas definitely Elm leans a lot more towards let's do it in Elm and then we get all the benefits. So I think in practice we probably get on a percentage basis more benefit from it, but I think they're both capable of it.
So hypothetically, the JavaScript ecosystem could get there, but it would kind of be on an app by app basis. It would require you to abide by specific constraints that a lot of apps aren't doing out there in the wild.
Yeah, and I think a lot of this comes down to ergonomics. I have kind of a whole series of thoughts I've been kind of fleshing out about just comparing how JavaScript has evolved over the past 10 years since 2008 when it got fast enough to build web apps in because of the great browser performance wars. And I think in a lot of ways, a lot of the churn people have been seeing and complaining about with like, oh my gosh, there's so much stuff coming out all the time and things are changing so fast, really dates back to that performance war that led to JavaScript being really suitable to have rich web apps where they're really client-side heavy.
This episode is brought to you by Linode, our cloud server of choice. It's so easy to get started. Head to linode.com/changelog. Pick a plan, pick a distro, and pick a location. And in minutes, deploy your Linode cloud server. They have drool-worthy hardware, native SSD cloud storage, 40 gigabit network, Intel E5 processors, simple, easy control panel, 99.9% uptime guaranteed. We are never down. 24/7 customer support, 10 data centers, 3 regions, anywhere in the world, they got you covered. Head to linode.com/changelog to get $20 in hosting credit. That's 4 months free. Once again, linode.com/changelog. This episode is brought to you by Raygun, who just launched their APM service. It was built with the developer and DevOps in mind. They're leading with first-class support for .NET apps, also available as an Azure app service, and have plans to support .NET Core, followed by Java and Ruby in the near future. After doing a ton of competitive research between the current APM providers, where Raygun APM excels is the level of detail they're surfacing. New Relic and App Dynamics, for example, are more business-oriented oriented, where Raygun has been built for developers and DevOps. The level of detail provided in the traces are amazing, the flame charts are awesome, and allows you to actively solve problems and dramatically boost your team's efficiency when diagnosing problems. Deep dive into root cause with automatic links back to source for an unbeatable issue resolution workflow. Learn more and get started at raygun.com/APM. Once again, raygun.com/APM.
One question I do remember asking 2 years ago, and you were teasing that, and I wanted the state of it because I haven't heard, was Elm on the server. Did anything ever come of that, or is it still just a spark, or what's the word? A pipe dream? A sparkle in your eye? Like, what's the situation? Is that going to happen? Did it happen?
No, that's a great question. It's not that it did happen. It's more that I think we have a much better understanding of what that looks like now. And basically, so we're, as was the case 2 years ago, and is still the case now, Elm does not have first-class server-side support, and that's intentional. We basically want to focus on the browser for now, but we're sort of keeping an eye on the server. So one of the perhaps surprising things that has been kind of guiding this design question of what should Elm on the server look like, if anything, is actually WebAssembly. So one of the things we've been sort of surprised by was when WebAssembly came out and discovering that actually this is a thing that all the browser vendors were on board with and were actually supporting. There became this question at some point of what does WebAssembly mean for Elm? And that kind of transitioned to discussions with some folks at Mozilla and asking about what's the garbage collection story going to be like, and asking questions about what should Elm's interop look like. And where we ended up was kind of discovering that actually it seems pretty feasible that Elm could someday compile just to WebAssembly, not to JavaScript at all, and actually that all of the existing JavaScript interop would still work. And the reason that's possible is that the way that Elm's JavaScript interop works is essentially through message passing. It's kind of like a pub sub, like maybe event emitter system. So you kind of, your Elm app sort of broadcasts events out to JavaScript and then listens for events coming in from JavaScript. And since that's the whole model, it's like that. And then also you can use some web component stuff if it's just view specific. Neither here nor there, but either one of those interop methods works totally fine if Elm is compiling to WebAssembly instead of to JavaScript. It can still talk to JavaScript just as easily as it did before. And nobody on the other side needs to know or care that it's compiling to WebAssembly under the hood, which could be even bigger for assets and also even bigger for performance, not just because it gets to have lower overhead, but also because it opens the door to really exciting concurrency stuff. So right now, Elm is actually very much intentionally designed to be a language that's potentially great at concurrency, but a lot of that potential is sort of goes to waste because JavaScript is single-threaded and web workers are, let's say, not usually great for improving performance of typical web applications in practice, even though in theory they might be able to because of serialization overhead. But a lot of that could potentially change if Elm compiled to WebAssembly. Now, if Elm compiles to WebAssembly, that kind of opens the door to Elm on the server having sort of a built-in way to sort of get off the ground in a way where, in an environment where concurrency actually matters a lot more and you can have a lot more potential benefits from it. Because on the client side, concurrency is basically a performance optimization. But on the server, it can be a pretty fundamental thing as far as throughput, as far as how much the server can handle, what kind of a load it's actually capable of processing. So the potential seems to be pretty high there. And I don't know if that actually ends up the way that we end up going with it. But it's been pretty fascinating to sort of realize, oh, hey, this actually seems like not only a plausible path, but actually a likely path at this point. And we've actually started basically making design considerations. Like anytime we talk about any kind of change that might impact the language or the core libraries, one of the questions that always comes up is, will this still be fine if we're compiling to WebAssembly instead? And it's basically become something of a design constraint.
So let me make sure I'm understanding you correctly. Are you saying that the work to make Elm compile to WebAssembly is the kind of work that you would have to do to run it on the server, and so the re-architecting will help you? Or are you saying that you could actually, once you compile to WebAssembly, then you just magically be able to run that compiled, WASM thing on the server?
Yeah. So I guess I kind of skipped a step.
Okay, thank you.
Yeah, no, that was a total leap.
That's all right.
So basically, Evan wrote out like one of the FAQs, is, hey, does Elm run on the server? And of course, I mean, Elm compiles to JavaScript. So literally, if you wanted to, you could compile Elm to JavaScript and run that.
Doesn't mean that you should, right?
Yeah. Well, more importantly, it doesn't mean you're going to have a good time if you do that.
Right, which means you shouldn't do it.
Well, so one of the big things that Evan points out is that basically, compiling to a particular target is about 5% of the work of getting to a good experience. The ecosystem is a huge deal, and so you have all of this enormous amounts of design work and also implementation work to say, what would a good Elm experience on the server be like? Like Elm has different design constraints than. I don't think there's any other language that has all exactly the same design constraints that Elm has. And so, there's definitely design work to do to figure out what would a nice experience look like. And actually, so ReasonML just ran into this kind of recently where, so ReasonML is another programming language that compiles to JavaScript. Although technically it's a syntax on top of OCaml, so it doesn't have to compile to JavaScript, although that's kind of what its big pitch is, because the syntax looks very JavaScripty. Anyway, a lot of people were saying, well, if I can compile ReasonML to JavaScript and I can also run OCaml on my server, why not use ReasonML on the server? And what quickly turned out to be the case is that, unfortunately, that's not enough to get a good experience right out the box. There's still a huge amount of work to do to basically build an ecosystem around that, to answer questions like, what should a web server look like? What should database access look like? There's all these different things, working with queues, working with third-party APIs, all of these questions that sort of have to be addressed before you have, something that's an adequate replacement from an ergonomics perspective for something like Rails or Sinatra or Express or any of the other alternatives that people commonly use. So what the folks who ended up doing that in the early days were basically doing on Reason is they ended up saying, well, okay, we're going to write our business logic in Reason, and then we're actually just going to end up compiling it to JavaScript and then doing a lot of interop to Express just to end up basically using Express as our application server. So, I guess technically you could do the same thing in Elm if you wanted to. Just use Elm for your business logic and then use a whole ton of interop to talk to, Express. But that's not really the sort of the Elm experience that people are accustomed to. People are accustomed to things sort of just working and being reliable and really only having to use interop in very exceptional cases, not as like a, bread and butter type thing. So I think that's kind of where the big amount of work to do exists, is like, what's the design of a really nice system? And that's what brings me back to WebAssembly is, what are the design constraints of that system? And if one of the design constraints is we're running in this single-threaded, albeit asynchronous environment, like because we're compiling to JS and running it on Node, that really constrains the API design space compared to if we're saying, yeah, we just have complete control over concurrency. We have first-class, threads that we can work with under the hood. We can offer a nicer API at a foundational level on which that whole ecosystem can be built if we're compiling to something that has a really nice notion of threading. And this also gets into other questions, like one of the things that Evan discovered in his research is that, so Evan's a big admirer of Erlang's supervision tree model and sort of the way that they handle fault tolerance and the way that they do servers, which has a lot of really great benefits. And one of the things that kind of came out of this exploration is that it seems like that those ideas are absolutely at their most effective when they are part of the foundational primitives, as opposed to when you try to opt into them using a third-party package, which happens in a lot of languages. So that's also sort of necessarily part of that initial design. And the way that Erlang's able to get really, really high throughput and really great fault tolerance is because it has really great concurrency primitives and also supervision built in from day one. So philosophically, I think the phrase Evan used was, I built Elm because I wanted to make something that had a credible claim of being the best experience you could get for building front-end applications. And for me as a user of that, I absolutely think he succeeded. But he basically said, look, if I'm going to do all the work to bring it to the server, I would want that same goalpost. I wouldn't want to just say it's like Elm, but also on the server, but rather saying,
Right.
even if you don't use Elm on the front end, this has a legitimate claim to being, potentially, if you're into the types of things that Elm does, this would be the best choice that you would possibly have out there for servers. And that's a much higher bar to clear and requires a lot more
that's
design
a longer field goal to kick. Yeah.
Well, especially because in the front end, it's basically like, who's your competition? It's like
Exactly.
JavaScript and TypeScript, and then like, several niche alternatives. On the back end, it's like Python, Ruby, Go, Scala, Java. I mean, the list just goes on and on. There's so many different alternatives that have been around for longer than, in some cases, longer than JavaScript's even existed.
Yep.
And a lot of them, have a lot more sort of claims to fame, like certainly Erlang in terms of robustness, or Java in terms of like sheer scale of some of those deployments. That Elm really has a long way to go before it can kind of say, yeah, we're a serious contender in that space.
So you're on the front line of Elm community and adoption. You go to the meetups, the conference talks, all this. Surely you hear a lot of people that are trying Elm or have tried to switch or adopt, and they go back to JavaScript for one reason or the other. I always think of myself with Sublime Text and VS Code. Every month or two I try out VS Code, and there's always just like one or two blockers. But I'm just like, yeah, I'm going back to Sublime Text.
Sure.
And so I don't do that. So surely you've heard some of those people where they say, yeah, this just isn't the way I like it, or that's not up to snuff, or I just can't get over this, that, or the other thing. What are some things people have been saying of why they don't adopt Elm?
That's a great question. So I can, I mean, you're right. I am very plugged into that, and I can like rattle off a list. So I would say they break down into a couple of different categories. A common one is team buy-in. So there will be one person on the team who's really excited about Elm, and everybody else on the team is just kind of like, we don't really care. We don't want to learn a new language. And the idea just kind of dies on the vine. That's sad when it happens, but at the same time, it's like, teams got to work together. So, I don't think there's really much hope for success of adopting something if, any technology, if only 1 out of N people actually wants to use it.
Right.
So that's certainly a barrier. Another one that comes to mind is basically learning curve. So Elm is a different programming language. That's just an innately higher learning curve than learning a library, learning a framework. I kind of think that's the progression. Like library tends to have the lowest learning curve. Framework is more than that. Language is more than that. Especially because sometimes when you get into languages, people end up with roadblocks that are not necessarily matters of it's too difficult to learn, but rather that people are just not interested in learning because there's like some aesthetic turnoff. So Elm does have a different syntax than JavaScript. Quite a lot of people say they like the syntax better, but there are some people who say, actually, I don't like the syntax as much, and this just bothers me too much. I can't get through the tutorial. So that happens. That's another reason that people don't end up using Elm. From a perspective of actual like APIs and libraries, I think the number one thing that people say, I don't know how many people walk away from Elm because of it, but I have heard at least one person say that they did sort of like a hack day project where they decided they were going to switch front end technologies, and they tried Elm, and they tried Vue.js, and they tried React, and they tried I forget what the other one was, but they ended up not going with Elm because of this, which is JSON decoders. And so basically, in order for Elm to have at the level of reliability that it does, it needs to not only say, like when you get some data from the server, it needs to not only say, I've got this data and now I can work with it. It actually needs to sort of like validate and translate it into a format that makes sense for Elm. So if you think about it, in the JavaScript world, if I've got a JavaScript object and I try to access a field on it and it's not there, I get back undefined, and that might very well lead to a runtime exception. The good old-fashioned undefined is not a function, that type thing. But in Elm, we don't really have that. That's all sort of checked by the compiler. Now, when you get back data from the server in JavaScript, you can sort of parse that, call json.parse, and it'll just give you back a JavaScript object immediately, or it'll throw an exception, which you can wrap a try catch around. But assuming it parses, then you've got an object, and now you're playing by the same rules as normal, which is to say, not much in the way of rules. And TypeScript basically does this the same way. It just sort of says, like, trust me, and you say, okay, I'm going to give up type checking right at the border. I'm not going to have the compilers help. I'm just going to assume that this JSON sort of fit the shape that I expected, and we'll just kind of go from there. Whereas Elm is sort of more serious about trying to maintain those guarantees as your program runs. And because the compiler can't possibly check what's coming out of your server because it's just a blob of data, it doesn't exist at compile time. There's nothing to check. Instead, it basically has this library called for JSON decoding that will simultaneously parse the JavaScript, but also sort of validate it against a schema, and say if that schema doesn't match what we expected, then it will fail, and you can do error handling, but you kind of have to specify the error handling up front. So it ends up resulting in a more reliable system, but it does mean that you actually have to write out a schema for all of your JSON endpoints. Whereas in JavaScript, you just don't. You just say JSON.parse, and it's just like, okay, good luck. Elm's not really into the whole, like, let's just pretend problems won't happen. It's like, no, we're going to try and actually handle the problems and do our best to make sure that if there is a bug, we know exactly where it happened and we can gracefully recover from it.
So this annoys some people because they're used to not having to do that, and now this feels cumbersome or
exactly
verbose.
Yeah. And I mean, people say it's a bunch of boilerplate, right? It's stuff that I don't have to do in JavaScript and I do have to do in Elm. So we're kind of like working on this, and in typical like sort of Elm design sensibilities, the goal is not so much to say, well, how can we make this less verbose? The goal is actually to say, well, what's the best way to do this? Like, what's the end goal here? Like, can we find a system where not only does it improve that, but actually we find something that solves other problems, which actually along the way solves that. And that's actually been something I've been doing a lot of research into recently. And the short answer turns out to be that the people who have the best experience with doing client-server data interaction in Elm tend to have a single source of truth for like the schema. So an example of this would be like at Google, they use protocol buffers for everything. And without going into too much detail, the relevant part here is that they have one schema file that says, here's what my data on the wire is going to look like. And then they have a tool that they run that generates both the client-side code that's going to decode that, and then also the server-side code that's going to encode that, and vice versa if you're sending data from client to server. So by having this single source of truth between the client and the server in this schema file, and then using code generation at build time to make sure that the two sides agree, you can actually sort of make sure that you no longer have the problem of, oh, whoops, I changed what my server is sending, but I forgot to update my client-side code to receive it. If you change the one but not the other, something in your build's going to break. So that has like a separate, really nice benefit, even beyond the, hey, it's a lot of boilerplate that I don't want to have to deal with. But as a nice consequence of that, it also addresses that, because now instead of having to define it in multiple places, you only define it in one place. You just say, like, here's my schema file, and then it's going to generate my code on the server. It's going to generate my code on the client. And so rather than having to sort of like write out, oh, here's the shape of my stuff on the client, and then also here's this separate decoder, you can just generate both of those at the same time for free from this one schema file. And while you're at it, also get better reliability, because your build will break if the client and server get out of sync. So we've got something like this. It's not literally protocol buffers, but on one internal service. And so far, the people who've been working on that system are like, yeah, this is great. This is like, everything's better. And so that seems likely to be the sort of like the shape of a solution to that particular thing that some people like, turns some people off from the language, where it's sort of like a solution to the direct pain point, while also making something else even nicer.
So tell folks who are interested in learning Elm, maybe they're JavaScript developers and they want to check it out, what's the happiest path to learning Elm?
Yeah, so I mean, the first resource I recommend to everybody is just the official guide. So if you go to elm-lang.org, Elm like the tree, then it's got a nice walkthrough that just sort of gets you start to finish. But it's pretty short, so that's kind of a pro and a con. It'll get you up and running, but it's not super in depth. So I'm writing a book, shameless plug, Elm in Action, which goes into a lot more depth. And it's pretty much designed at people who know JavaScript, at least to some extent. It doesn't expect that you're a JavaScript master by any stretch, but it uses JavaScript as sort of a comparison point. So I think if you're coming from JavaScript, that should be a nice introduction. If you prefer the video thing, I've also got a course on front-end masters, which I recently updated for Elm 19. And I've got 2 courses on there. One is Intro to Elm, which is basically a day-long course, just gets you zero knowledge of Elm at the beginning, all the way up through building an application and kind of working on a larger Elm code base that does single-page application stuff and HTTP and all that. And then the advanced course is for, maybe come back in a couple of months if you've been digging the Elm thing and get into some of the really cool advanced stuff.
Very good. Thanks, Richard. This has been a lot of fun. Thanks for coming on the show.
All right. Thanks.
Thanks for listening to this episode of The Changelog. Assuming you're loving this show, rate, review, or recommend it wherever you listen from. It helps us reach new, awesome people. If this is your first time listening to The Changelog, you can find more episodes and our other compelling shows at changelog.com/podcasts. The edit and mix was done by me, Tim Smith, and the music, as always, is brought to you by the one and only Breakmaster Cylinder. Thanks to our sponsors, Hired, Rollbar, Linode, and Raygun. Bandwidth is provided by Fastly. Learn more about them at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com, and we're hosted on Linode servers. Head to linode.com/changelog. Thanks for tuning in. See you next week.